Good morning, everyone.
Good morning.
Good morning.
All right, well, let's start with, okay, so yesterday, is there anyone that's here today that wasn't here yesterday? Let's see, Avrin, were you here yesterday? Okay, all right. Let's see, Winslow, I can't see you guys. Oh, there we go. All right. All right, well, let's go through the roll here for today. Rex?
Here.
Alana?
Here.
Diana?
Here.
Taylor?
Here.
Auburn?
Here.
Cameron?
Here.
Andrew?
Here.
Shandon?
She's here.
Okay, and Junior?
Here.
Hayden?
Here.
Jordan?
Forgot.
Here.
Ellie?
Here.
Dominic?
Here.
Brooke?
Here.
All right. And so everyone was here yesterday? Is that right? Okay. Oh, wait. I forgot to mark people present. There. Okay. All right. All right, so does anyone have any questions, comments, concerns before we get started today on chapter 8? So I did fix those quizzes. I had actually, I forgot that this class that we were doing the quizzes, keeping them open till the tests. And so, so I think I got that I think I've got that fixed. Okay. All right. So now, just before we get started, let me just say, just talk for a second about the midterm. Okay. So in the chapters that we're covering here in this semester are 6, 7, 8, 9, and 11. You might remember we did chapter 10 last semester. And so we're starting here on chapter 8, but what I'm in chapter 8 has I believe it's 6 sections. Yeah, 6 sections. And so what I'm hoping is if we can get through 8:3, I'm pretty sure we're not going to be able to finish chapter 8 before the midterm, and that's okay. But I'm thinking that we will be through 8.3. So if that's the case, then what we're going to do is actually, no, not 6 through 8. This, we're not going to finish chapter 8. So it's just going to be chapter 6 through 8.3 will be on the midterm. So chapter 6 through 8.3 will be on the midterm. And then the midterm, the actual dates, let's write that down. Okay, so let's see. I believe the 11th through the 15th is spring break. Okay, so we have spring break. So that's March, well, for us, 11th through the 14th. But I'm going to put the 15th to include the Friday. Okay, and then we'll come back, and then you will have a sub on March 18th and 19th. And then the midterm will be March 20th through the 21st. Okay? So that's a Wednesday and Thursday. Okay? And so that's kind of the plan. Now, if you need anything opened through 8:2, if you've missed it and it's closed, like from chapter 6 or something, shoot me an email and let me know that you're going to tutoring, and then I'll reopen that. But once we take the midterm, basically chapter 6 and chapter 7 are going to be locked in. Okay? And we won't go back and open up any of that. Okay? All right. So as we get closer and I get to specific, like the numbers, how many questions, all that kind of stuff, I'll let you know all that too. Okay. But it will be on the Moodle in the 2 days, similar to last semester, how we did that. Okay. Okay. Any questions?
What if we're not going to be here on the 20th?
Then you need to let me know ahead of time, and we'll probably have to work something out for you to take both parts on the 21st or something like that. Because anyway, we'll have to work out some schedule with you and your talent aid, because it has to be proctored. Okay, so as long as you can work out a schedule to be done like on the 21st. So like if you miss part 1 because you're not there, or you miss part 2 because you have a game or something, if you want to work out a schedule with your talent aid, and then just let me know with specific times, and then I can unlock it, and that'll be okay. We'll figure it out. Okay. Any other questions? Okay, great. Well, let's go ahead and get started here. So chapter 8, I guess before we jump into 8.1, chapter 8 is on what's called additional topics in trigonometry. And pretty much the only section that I know that you've been exposed to before is the first one. After that, everything might be new. So we'll just see how that goes. But this first section on the law of sines and the law of cosines, you have that in usually, geometry for sure, and algebra 2 sometimes. So, but I know you've seen this before. And so this section, I'm pretty sure you're not going to have any trouble with, but we'll go through it. Okay. Oh, now I just sent out because I told you I'm on the search committee and the hours are just killing me, but I did get out the guided notes for 8.1. Did everybody get that? Yes. Awesome. Doe City. Is Miss Buckley there?
Yeah, she's going to get it right now.
Oh, awesome. Okay. All right. You'll be fine then. Okay, great. Yeah, I just barely sent it, so don't judge her. Okay. So Anyway, so law of sines and its uses, law of cosines, and then areas. That's kind of a big thing. And so we'll work on that. Okay, so basically we're going to be working with solving what we call oblique triangles. Okay? So triangles that have no right angles. How do you find the third side? How do you find the missing angles? Now, typically we use the lowercase letters to represent the sides and the capital letters to represent the angles. Sometimes they'll use Greek letters, whatever. But one thing I do want you to pay close attention to is that the capitals, the capital C for like angle C is opposite side C. And angle A is opposite side A. And so that's going to be important when you set things up and as we write the equations. Okay, so the first one is the law of sines. So to solve an oblique triangle, you need to know one of the four cases, okay? So for the law of sines, we need to, now, does anybody remember from geometry what, like ASA, what does that stand for?
Angle, side, angle.
Yeah, excellent. So we know like two angles and then the side in between them. Or angle, angle, side. Okay, or side, side, angle. For the law of cosines, if we know all three sides or side, angle, side, that's when we're going to use the law of cosines. Okay, now I'm going to teach you another way to remember all of this, but for now you can just kind of write that down. So again, what that looks like, so this would be like side, angle, side. Or this would be side, angle, side. So where the angle is between the two sides, okay, that you have. Okay. All right. Okay, so the law of sines is Okay. So when we're writing down the law of sines, if you want to just be succinct or whatever, you could just write what's in this first box. So the sine of angle A over side A is equal to the sine of angle B over side B. Now, you could also include this third fraction, but we only use two of them at a time. But it doesn't matter. You could use these two or whatever, but we only use two parts of it at the same time. The other thing is that it doesn't matter which one goes on top, if it's the side or the sine of the angle. And so this is the same thing. It's flipped. Okay. And so some people like putting the side on top. It really doesn't matter. The math is no easier either way. So it's just whatever you want to do. Okay. So you can write all of this down, or if you just want to write what's in one box, that's okay too for the law of sines. Okay, so let me show you how we work it. Okay. All right, so it says for the triangle, let's say that angle C is 102.3 degrees. And usually we're going to do, in this section, we're going to be in degree mode for both law of sines and cosines. And angle B is 28.7 degrees, side B is 27.4 feet. Find the remaining angles and sides. So to find the remaining angles and sides, another way we could say that is solve the triangle. So to solve the triangle means make sure you know all the same angles and sides. All right? Now, the first thing that I want you to make sure you understand is how to set up the triangle. All right? So I know this is just a an example here, but just on some scratch paper or on the side of your notes or just whatever, I'd just like you to draw the triangle here just for practice. So draw a triangle that has these two angles and this side, and I want you to label A, B, and C where they are. Because this is an important prerequisite skill. Now, you don't have to draw a triangle in this, but you're going to see later in this lesson, either today or Thursday, why drawing the triangle is going to be important. Okay? Now, so your triangle should look something like that. Now, if you have the angle over here, that's okay. You know, really the main thing that you have to have when you're drawing this triangle is this angle that's 28.7 has to be opposite this side that's 27.4. So however you have your triangle, that's okay, but those have to be opposite each other. Okay? Any questions on that? All right, now, to find the third angle, remember that all of the angles of a triangle have to add up to 180. So if you know two of them, you subtract them from 180 and you get the third angle. Okay? All right, now, when you're setting up the law of sines, what you need is an angle side pair. And that's where I was talking about that it's important that this angle be opposite this side, because that's what I call an angle side pair. All right? So we're going to use that when we're setting up the law of sines. Okay? Okay, so remember I said you could write it either way. So it doesn't matter if the angle's on top or the side's on top. But I'm going to do this, the angle side pair is 27.4 is the side over the sine of 28.7. Those have to be together or it's going to be wrong. Okay? Now, I choose which side I want to find. I can find either side A or side C because I know both of those angles. So it doesn't really matter. Let's do A over the sine of 49 degrees. Okay? So now once you set it up using the law of sines, to solve for A, you're going to cross multiply. Okay? So then what you end up with is, see, it's kind of like you're multiplying each side by the sine of 49. And so, but in a sense, you're cross multiplying. So it's 27.4 times the sine of 49 divided by the sine of 28.7. And so this right here is what you would put in your calculator. So you make sure you're in degree mode, and then you put that whole thing in the calculator, and that will be little a, side A. Okay? Now, so I'm going to just, when we do the practice problem, I'll make sure that we put it in the calculator right. But so for this one, you put it in the calculator. Again, you round to, I like 3 digits, so 43.061. And the units will be the same as the units for the other side. So since that's in feet, then my units here will be in feet. Okay, now, so once you have one side, can you use the Pythagorean theorem to get the third side? So now we have two of the sides. So could we use the Pythagorean theorem to get the third side?
No.
No, why not?
It's not 90 degrees.
It's not a right triangle. Excellent. Excellent job. Okay? That's an important idea. Okay? So now you basically use the law of sines again. Okay? Here, let's start over. Let's use the law of sines to set up the third one. Okay? So for side, so again, we use the angle side pair that you know. So 27.4 divided by the sine of 28.7. So that's an angle side pair equals, okay, so now we're looking for side C over the sine of the angle opposite C, which is 102.3. So the sine of 102.3 degrees. All right? So then when I cross multiply, I'm going to get, let's see, where's that one? So then I put in the calculator. 27.4 times the sine of 102.3 equals C times the sine of 28.7. Okay? So this part right here. And so then to solve for C, I would divide by the sine of 28.7. So now I put that in the calculator, and that gives me the third side. So 55.75 feet. So 27.4 times the sine of 102.3 divided by the sine of 28.7. So you can put all that in the calculator at once. All right. So let's see if you can do practice 1A. I'll leave this up for a minute. Oh, let's see. So Josie, did you guys get it? Okay, awesome. All right, so Caden, what's the measure of angle C?
105.
105. Okay. All right, any questions on that? All right, so Caden, what's the length of side B?
I don't know. I didn't really get that far.
Okay, I'll wait. There's no problem. We're not trying to hurry you. If you get stuck, let me know. But
I'm kind of confused and I don't really know what to do.
okay. So to use the law of sines, we need an angle side pair. And see how we have this angle here and this side here that's opposite it. And so that's what we're going to use. So we say, okay, so using the law of sines, here, let me write it up this way. So I say 32 over the sine of 30. So that's my angle side pair. And then if I'm looking for side B, then I put B over its opposite sign. So the sine of 45. Okay? So that's the proportion I'm going to solve to find B. Okay? So when I cross multiply, I'm going to get 30 times the sine of 45, 32 times the sine of 45 divided by the sine of 30. Okay? All right, so Caden, if you would put that in your calculator, and let's see what you get. So 32 times the sine of 45 divided by the sine of 30. You need to make sure you're in degree mode.
$45.25.
Okay. 45.255. Good. All right. So all we need now is side C. All right, Dominic, what would side C be?
61.8.
61.819. Good, good, good. Any questions on that one? All right. So the key is making sure you have that angle side pair. Otherwise, the law of sines won't work. Okay. Okay. So when solving triangles, a careful sketch is useful as a quick test for the feasibility of an answer. All right, what does that mean, feasibility? What does feasibility mean? Go ahead.
Like the truthfulness, or like it's like an accurate.
If it's even possible. Okay. Sometimes, you'll like, let's say the angles given make it so that you can't even draw a triangle. We'll talk about that. Okay, remember the longest side lies opposite the largest angle, and the shortest side lies opposite the smallest angle. Okay. Okay, so it says a pole tilts toward the sun at an angle of 8 degrees from the vertical. So if it wouldn't even hurt to draw the sun here. Okay, as you're drawing your figure. Okay, here's the sun. The pole tilts at an angle 8 degrees from the vertical toward the sun. Okay. And it casts a 22-foot shadow. So the shadow is going to be on the opposite side of where the sun is. So the shadow is going to be this way. And so you draw your shadow this way. Okay? Now, this kind of stuff, like where to draw the tilt, where to draw the shadow. I mean, if you had the sun on this side of the pole, the shadow would be over here. Everything would be flipped. And that's okay. That's okay. But when there's certain terms, like this with the shadow and so on, where doing some of the practice exercises will help you set up the triangles. Okay. Sometimes when students will email me and they'll say, "Oh, I didn't understand this quiz question because it says the shadow and I didn't know where to draw the shadow," and so on. And it makes me realize that they didn't practice too much. Otherwise, those type of problems would have been worked out. Okay. They would have figured it out. All right. So, cast a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So if you're at the tip of the shadow looking up, that's the angle of elevation. So going up from the tip of the shadow is going to be 43 degrees to the top of the pole. All right. How tall is the pole? So here we're wanting to know this length of side A here. Now, so we have this angle is 43. What would be the measure of the angle that the pole makes with the ground? If it's 98, because it's 8 degrees from the vertical. Okay? But see, drawing it, if you're not careful, you might think it would be like 82. You'd subtract the 8. And that's why drawing the picture would help you see, okay, from the vertical, it leans 8 degrees. So this is 90 plus 8. So this angle B here is 98 degrees. Okay? Now, we know this side is 22, but do you see we don't have an angle side pair? See, we know this angle and this angle, but we don't know the sides opposite them. The only side we know is C, but we don't know angle C. So, go ahead, Ellie.
Wouldn't you just find it though, just by
subtracting? Yes. Well, but what I'm saying is that's what you've got to do first to get that angle side pair. So yeah, you just find it by subtracting these two from 180. Okay? So you're going to get 39 degrees. for angle C. Now, once you have that, now you can use the law of sines because you have an angle side pair. So you say, okay, so you're looking for side A. So side A over the sine of 43 equals 22 over the sine of angle C, which we discovered was 39. And so that's what you're going to solve. So you cross multiply. A times the sine of 39 equals 22 times the sine of 43. And so then now you'll put in your calculator 22 sine of 43 divided by the sine of 39. And then you get your answer. All right, so go ahead and try practice 1B. All right, so first, let's see if your triangle is correct, okay? So in this case, the 30 meters is opposite the direction of the lean. So if the tree is leaning one way, then the 30 meters is the other way. So, and since it's 6 degrees from the vertical, then this angle is 96 degrees. And the angle of elevation is 22 degrees, 50 minutes. All right, any questions on the triangle? Okay, Andrew, what is the third angle?
Shoot, sorry.
For C?
What's the angle? What's the third angle up here?
61.2.
Okay. Now, since because there you're rounding, what I would recommend you do is actually keep it in terms of minutes, because this one's in minutes. So make it 61 10 minutes, because 0.2 is rounding. And so if they're giving you a degree in degrees, minutes, seconds, that means they want the angle pretty exact. Because if you round, you're gonna it might not be to the accuracy that you need. Okay, so imagine if you're in Afghanistan and you're calling in an airstrike, you wouldn't want to round. You see what I'm saying? I mean, you got to be exact because otherwise they bomb your troops. Your own guys will bomb your troops. So you've got to be precise. So, okay. So 61 degrees, 10 minutes. Okay. All right. So all right. So Ellie, when you have the final answer, let us know.
So the angle opposite of the 96 degrees is 34.057 or 58.
So, well, you mean this side?
Yeah, the side, yeah.
Yeah, I don't need that side.
Oh, what
I
side
need
are you
this.
looking for?
I need this H right here, this side.
Oh, okay, one sec.
So I need the side opposite the 22 degrees 50 minutes. So if it says solve the triangle, then you do need to find all the sides. But in this one where it says just find H, then that's just one particular side.
So it's 13.289.
Okay, let's see what we've got. 13.289. Great job. And the units there would be meters because that's the units of the other side in meters. Okay. So again, you use the angle side pair that you know. 30 over the sine of 61 degrees 10 minutes equals H over the sine of 22 degrees 50 minutes. And so then when you cross multiply 30 times the sine of 22 degrees 50 minutes divided by the sine of 61 degrees 10 minutes, that's what you put in your calculator to solve for H. All right. Any questions on that? Okay, now you might remember from geometry that if you were trying to prove triangles congruent, you would have things like side or angle side angle or side side side. But the one case that you couldn't use was angle side side or side side angle. Okay? And the reason why is because when you have just side side angle, that's what we call the ambiguous case. Because when you're given that information, it's possible that no triangle is possible. No triangle exists that has that given information. Or it's possible that one triangle exists. Or it's also possible that two triangles might satisfy those conditions. So that's why you can't use SSA or ASS to prove triangles congruent. Okay? You make an angle side out of yourself is what my teacher told me. Okay? All right, so let's kind of talk a little bit more about that. So these are the theorems, like, so side, you'd go and you'd prove if these sides are equal, these sides are equal, these sides are equal, then the triangle's congruent, okay? So, but side angle was the ambiguous one that you couldn't use. All right, now, this diagram I find is extremely helpful for me, but this is not in your book, okay? At least not exactly like this. Let's see if they have. I just remember just writing this down. They have part of it. They have this part. But let me explain kind of how you do it. Okay, so if you're given a side, and an angle, then to determine how many triangles are possible, you first determine if the angle that you're given is obtuse or acute. Okay, so that's like the first question you ask yourself. All right, if it's obtuse, then you could have either one or none possible. If it's acute, you could have none, one, or two. Now, let's go back to the obtuse case. What you do there is you compare the two sides that you're given. If A is less than or equal to B, it's not possible. If A is greater than B, then yes, it is possible. You have one triangle. All right, now, if the given angle is acute, then what you do is you determine the height of the triangle. And so H is B sine A. So again, you're given side B, you're given angle A, and so you compute the height of the triangle. Then the height will help you determine how many triangles are possible. So if A is less than H, nope, can't happen. Because see, what happens is if A is less than H, A will never reach the third side. So it doesn't make a triangle. If A equals H, then you have a right triangle, and boom, it'll work. You'll have one possibility. Okay, if A is greater than B, then A will be long enough to hit the third side, so you'll have one triangle. All right, and this is the tricky one right here. When you calculate H, if H is less than both sides, A and B, then there's actually going to be two different triangles. Okay, so I've drawn kind of one, the dotted side could be the third. So you could have this little triangle right here, this sliver, or you could have this whole thing that would actually satisfy the given conditions. So if H is less than both sides, when you calculate it, then you'll have two possible triangles. Okay, so let's look at let's just look at practice 1C. So it says for a triangle having A is 25 degrees, B is 54, and A is 26 feet, how many solutions or triangles are possible? So first of all, is the angle obtuse or acute?
Acute.
Acute. because it's less than 90. So it's those first four. All right. So then what you have to do is calculate H. All right. So H is 54. So B sine A. All right. So put that in your calculator and tell me what you get for H.
$22.821.
Okay, so 22.821. So now, using that information in the chart, can anyone tell me, is the answer going to be 0 triangles, 1, or 2? If H is 22.821, B is 54, and A is 26. So how many solutions are there?
B1.
Okay. No,
Or
it's
two.
going to be 2 because H is less than both. If H is less than both of them, then it's 2 triangles. Okay. All right. Whoops. Let's go back to here. Okay. Now, so if A is less than H and A is acute, then there are no solutions. Well, or if A is less than or equal to B and A is obtuse, there's no solutions. Okay, so let's look at this one. So show that there is no triangle for A is 60 degrees, A is 4, and B is 14. Okay, so here is the angle is acute or obtuse?
Acute.
Acute, okay? So what we're looking at, so if A is acute, we want to see if A is less than H. Okay, so here's A is 4. Okay, now how do we get H?
What's H?
It's B sine A.
B sine A, good. So B sine A, so if we plug in 14 for B and the sine of 60, okay, calculate H for me. Somebody said it, 12 point something?
12.1.
Okay, and so now is A less than H? Yes. So if A is less than H and it's an acute angle, then no triangle possible. Okay, so we're about out of time. So we'll kind of pick it up from there tomorrow or Thursday, and then probably finish 8.1. And then I'll be sending out this week the other guided notes for the rest of chapter 8. All right. All right. Well, thank you, everyone. Any questions? Got 5 seconds.
Could you go up a little bit?
Could I scroll up?